Hello, this is Professor White. Today we'll talk about variation and some word problems related to variation. This is in the Rational Expressions chapter, usually in a beginning algebra book. Okay, a variation. We call it direct variation when we have two parameters and one parameter increases and the other one automatically increases. Okay, and the second case is one parameter decreases, the other one automatically decreases. Okay, I'll just show you an example. And you say A is in direct variation with B when they both increase or they both decrease. For example, calorie intake and weight gain. So if I take more calories, I'll have more weight. So A equals K times B. This one is called constants of proportionality. Proportionality constant. Okay? And A is one of your parameters and B is the other parameter. A equals K times B. Direct variation. Inverse variation. That happens when A increases and automatically B decreases. They are connected. Or A decreases, automatically B increases. All right, an example. When you go faster, speed goes up and the time to get there goes down. In other words, A is the speed, it goes up, and then time to get there goes down. All right? You can also write it A equals K times 1 over B. Inverse variation, sometimes they call indirect variation. You'll see both ways. Sometimes instead of variation, they use the proportional, inversely proportional. There is a relationship of inverse variation. There's a relationship of inverse proportionality. You'll hear all these words, but they all mean the same thing. So when you have inverse variation, A equals K times 1 over B. Okay, let's do an example. A direct variation example. Hooke's law states that the distance a spring is stretched varies directly with the force applied to the spring. So distance varies directly with the force. Distance equals K times F. That's the first step. You write the proportionality formula. Second step, you plug in numbers. If a force of 4 newtons stretches a spring of 80 centimeters, let's change that to 5 newton. Because that's what it says in there. If a force of 5 newtons stretches a spring of 80 centimeters, how much force is required to stretch a spring of 128 centimeters? So what you do, you plug in the numbers that you see in there. So 5 is 5, and 80 is 80. 80 equals K times F. K times F, K times 5. Now distance is measured in centimeters at this point, and F is measured in Newton. So you have to be consistent with that. 80 equals K times 5. That means K equals 80 divided by 5. Is that right? That's correct. So K is 16 when you have the force in Newton and distance in centimeters. Okay. Third step. It's going to say how much force is required to stretch a spring of 128 centimeters. So it says what happens when the distance is 128 centimeters. What is F? That's the question. All right, remember we found K from the other page, so this is the third step, to be 16 when these guys are in centimeters and Newton. Okay, so let's plug in the numbers. D equals 16 times F. So you just plug in the numbers. Now you're going to put in the new set of numbers. So it's 128 centimeters equals 16, which is the K, times F. And F is the one that we are trying to figure out. So F is going to be, if you divide both sides by 16, 128 over 16. And that's going to be 8. And 8 what? And that is supposed to be in newtons. Okay? So in 4 steps, we got this direct variation problem done. Let's have an inverse variation problem. Boyle's law states that if temperature is constant, the volume of a gas in a container is inversely proportional to the pressure applied to it. Okay? The volume is inversely proportional to the pressure. Volume is inversely proportional to the pressure. All right. Now the next step, so that's step 1, we are going to find K. And how are we going to find K? We are going to put in the numbers that we know. If a gas has a volume of 4 cubic feet, when the pressure is 10 pounds per square foot, find the volume when the pressure is 2.5 pounds per square foot. Now, I'm supposed to find the K from here. I write down the numbers. So what are the units? I usually mark the first step equation with the units so that I don't get confused. The volume I am measuring in cubic feet, and this one I'm measuring in pounds per square feet. So I'm going to be consistent with that. So I don't have to worry about anything else. Now, let's go and let's find out. So how can I solve K here? I can solve K here by multiplying both sides by 10. And look what happens. K equals 10 times 4, 40. All right, so that gave me the constant from the step 2. Now that I have step 2, step 3, I'm going to write it with the K that I found. V equals K times 1 over P. K is 40. V equals 40 times 1 over P. And the last step, I plug in the numbers. It says, what's the volume when the pressure is 2.5? So put 2.5 and 40. Just instead of P, you put 2.5, you get 16. And 16 what? And remember, that's in cubic feet. And that's pretty much the end of the question. Okay, now we are talking about joint variation. Joint variation is something when you have more than 2 things related to each other. They can be directly or indirectly related. If they are directly related, they will say they are there's joint variation. They are not going to say they are not going to use the word inversely. So if they don't use the word inversely, you just assume it's direct. So let's look at that. If the width of a rectangular solid is held constant, the volume varies jointly with the length and the height. It didn't say inversely, so that means they are direct variation. V equals volume varies jointly with length and the height. Here's my formula, step 1. Now I plug in the numbers to step 2. Volume varies jointly with length and height. This is done. Step 2, numbers. The volume is 100 cubic inch, so I'm going to put those units in here. The length is inches, and height is also inches. So let's put them in. 192 cubic inch equals K times length is 8, and height is 6. 192 equals K times 48. So you go and you divide both sides by 48. And I get 4. Okay, so I found the 4. So I'm going to go and to the third step. Volume equals KLH. Volume equals 4 is the one that I found. Now the last step is going to be put in the numbers and answer the question. They are saying when the length is 7 and height 12, what is the volume? So here it is, 7 and 12. Multiply them out, 28 times 12, that's 336 cubic inches. Okay, so that is the end of the variation section.